Example 2. If the gradient at a point xy on a curve is given by 6x squared and the curve passes through 0 and 12, find the equation of the curve. So we've got the derivative. So what we're going to need to do is take that derivative, find the original equation. We'll get a plus c. Then to find the plus c, I'll need to substitute those coordinates in there to solve for c. In much the same way you might remember by being the process of finding y equals mx plus c for a straight line. Let's give this one a go. There's the antiderivative. And now to solve for c, I just need to substitute those coordinates in there. So x will be 0, y will be 12, and I'll solve for c. And there's our final answer. Example 3. Find y in terms of x in each of the following. The derivative is equal to 2x to the power of 4 plus x, and y equals 0 when x equals 0, or passes through the origin. Same exact process. I'm going to find the antiderivative and find c by substituting x and y, in this case, for 0. And I think that would therefore indicate that the plus c should also be 0. But let's go and find out. And there's our final answer. Example 4. The graph shows the derivative against x for a certain curve with the equation y equals f of x. Find f of x given that the point 0, 4 lies on the curve. You can see here that the derivative graph is a linear graph. If you remembered anything about the matching of a derivative graph with its original, the original is likely to therefore be a parabola. So we'll need to go and identify the equation of this line first. So it'll be in the form of y equals mx plus c, and then do the antiderivative of that, and then we'll need to solve for c. So an extra step. So we're not just given the linear equation, we have to find it first. So we found that derivative equation by finding the value of m by doing y2 minus y1 over x2 minus x1. That got us our m value there. Also quickly, there's 5 up there would suggest that that would be the y-intercept of this linear graph. And from that point, I was then able to do the antiderivative to get to this point here. So I know that the original equation, as I predicted, was going to be a parabola. And now to find the plus c of the original graph, what I need to do is I'll need to substitute 0 and 4, x equals 0, y equals 4, to solve for c. Unfortunately, my examples are all a bit easy. I can assure you, not all of them are, not all of the time you're going to be given a coordinate where the x is 0 and therefore you can cancel everything out and just make that final answer c. But nonetheless, that is the procedure that you need to do. Example 5. The curve for which the derivative is equal to 2x plus k, where k is a constant, is such that the tangent at 3, 6 passes through the origin. Find the gradient of this tangent and hence determine the value of k, the equation of the curve. So we have got an extra step to do here. The derivative of the curve is 2x plus k. So that means that and it is a tangent at the coordinates 3, 6 passes through the origin. So let's start with just this small little nugget. So I've got a tangent here that's going to be in the form of y equals mx plus c. So we have to find what the m is. So the m we know is going to be in the form of this derivative, but with a 3 substituted in there. So this will be 2 times 3 plus k. That's going to be the derivative or the gradient of my tangent line. I also know that it passes through the point where y equals 6. So I can use this as well as the 3 here to go and determine the value of c for the tangent line. Now we can see here we've got a rather revolting equation here. This is the gradient, or this is the equation of the tangent. But we still got these rather dratted k's in there. But the other small factet that we've been given is that this tangent passes through the origin. Origin meaning that it passes through the points 0, 0. So that means when y equals 0, x has to be equal to 0, and we can use this to solve for k. And thus we have found that k is equal to -4. So we can substitute that back into the original equation, and we have found our answer for A. For B, we now need to find the equation of the original curve. So let's fill in the information that we've got. So for B, we know that the derivative is going to be equal to 2x minus 4. So now to find the original equation of the curve, we're going to need to find the antiderivative. That's going to get a plus c. Now we need to know which coordinates to substitute in. So the tangent hits at 3, 6, and 0, 0, but the original curve does not go through 0, 0. The only one it definitely goes through is this 3, 6. So that's the set of coordinates we will be substituting in once we've done the antiderivative of this derivative. You'll notice there, if you pause the video, I made a silly little mistake. I got too fast and I accidentally said that x squared was an x cubed, but nonetheless, I realized what my problem was, and now I have found what my original equation is.